Today's class, we are going to learn regarding correlation coefficient. So in the previous class, we already learned about what is correlation, and in this class, we will detailedly learn about what is called Pearson's correlation coefficient. So we'll see the definition of correlation coefficient. So the correlation coefficient is defined as the strength and direction of the linear relationship between two quantitative variables. So this one we already discussed in the last class. So the coefficient of correlation will tell you the strength and the direction of the relationship existing between the two quantitative variables. So we'll see what is called Pearson's correlation coefficient. So this is introduced by Karl Pearson and hence it is known as Pearson's product moment correlation coefficient. And as I said you earlier, the Pearson's correlation coefficient is symbolized by the small letter r. Okay. Let's see what are the purpose of this Karl Pearson's coefficient correlation. So mainly this correlation is used to examine whether an increase in one variable may lead to an increase or decreases in the other variable. Okay. And let's see some of the properties of this Karl Pearson's correlation coefficient. So the Karl Pearson's correlation coefficient always range between -1 and +1. Okay, and if you are getting a R value of +1, which indicate that a perfect positive correlation between two variables. So what is a positive correlation? Positive correlation means any increases in one variable leads to an increases in the other variable also. So that's correlation is known as positive correlation. So if the R value is +1, which indicate that there is a perfect positive correlation existing between the variables. And suppose if the correlation coefficient value is -1, which indicate that there is a negative correlation. So what is negative correlation? An increases in one variable may leads to a decreases in the other variable. So that is known as negative correlation. So if the R value is -1, which indicating that a negative correlation between the variables. And one more, if the correlation coefficient value is 0 or it is close to 0, which indicate that there is no correlation between the variables. Okay, so it usually range between -1, +1 and 0. +1 indicate a perfect positive correlation, a -1 indicate a perfect negative correlation, and a value which is close to 0 indicate there is no correlation between the variables. Clear? Next, we'll see the direction of correlation coefficient. So usually the direction is mainly indicated by the sign that can be plus sign or minus sign. So these signs will show you the direction of the relationship. So suppose if the R value is ranging between 0 and +1. 0 and +1, which indicates a positive correlation or a direct relationship. And if the correlation coefficient value range between 0 and -1, which indicate a negative correlation or an inverse relationship. Clear? So the direction is always indicated by plus sign and minus sign. So +1 indicate a positive relationship and the value between 0 and -1 indicate a negative correlation. Next is regarding the strength of correlation coefficient. So here the absolute value of R, which may indicate the strength of the relationship. Okay, and there is no rules which says that there is a moderate relationship or a weak correlation like that. There is no as such rules, but certain guidelines are given and we are following that guidelines. Okay, understand? So suppose if you are getting a R value which is more than or equal to 0.8, which indicate a strong correlation between the variables. And if the R value is less than 0.8 indicates a weak correlation. And suppose you are getting a value that is range between 0.5 and 0.8, which indicates a moderate correlation. So always when you do the mathematical calculations, look for the R value, and if the R value is more than 0.8, which indicates a strong correlation, if it is less than 0.8, which indicate a weak correlation, and if the value range between 0.5 and 0.8, which indicates a moderate correlation existing between the two variables. Okay. Now we'll see how to determine the correlation coefficient, or how we can determine the R value. So there are equations available. So once we need to find out the R value, and after that statistical tables are available to see whether the correlation coefficient obtained is statistically significant. Okay, and we have to compare our value with the statistical table value. And if the correlation coefficient value is greater than the statistical table value, there is a significant relationship existing between the variables. And if the obtained correlation coefficient is less than the statistical table value, the relationship is not statistically significant. So these statistically significant and all we need in case of testing the hypothesis. So that time our R value has to be compared with the statistical table value to identify whether this is statistically significant or not. Okay. So this is the Karl Pearson's correlation coefficient equation, that is R is equal to sigma xy minus sigma x into sigma y by n divided by square root of sigma x square minus sigma x the whole square by n into sigma y square minus sigma y the whole square divided by n. So this equation, it will look like a very big equation, but it is very easiest one. I will explain each components. So where x is the first variable and y is the second variable and n is the number of pairs. Okay, so we'll discuss regarding how we will do the mathematical calculations of this equation in the upcoming classes. So I hope you got an idea regarding what is Karl Pearson's correlation coefficient. Okay, so thanks for watching, students.